This lesson is for 9.2, arithmetic sequences and partial sums. The objective is to write rules for arithmetic sequences and find sums of arithmetic series. Key vocabulary: arithmetic sequence is a sequence where the difference between consecutive terms is a constant. The common difference is that constant that is the difference between the terms. An arithmetic series, of course, would then be the expression formed by adding the terms of an arithmetic sequence. So there was a mathematician named Friedrich Gauss, and he lived, I don't know how many hundreds of years ago, but considered to be probably the smartest mathematician of all time. And the story goes that when he was like 5 years old, and in his class, his teacher wanted to get something or have the students do something that would keep them busy. And at that point, students of different ages were in the class. And so she told them to sit down and add the numbers from 1 to 100. Gauss was about 5 at this time. He came back much quicker than she was expecting and actually had the correct answer. So the teacher, of course, wanted to know how he did it. And Gauss had figured out very quickly that if he listed all the numbers from 1 to 100, ascending from 1 to 100, and then beneath that listed the numbers from 1 to 100 descending, and added vertically that every single one of the sums is 101. So basically, you would have 1, 2, 3, 4, all the way up to 100 times the same number, 101, which was the first term in the sequence plus the last term in the sequence. The only problem with this is that we listed the numbers twice. We listed them once ascending, we listed them once descending. So we have to divide this total by 2. And so, of course, a sub n in this case, a sub 1 plus a sub 100, because that would be the last term, over 2, which is equal to 100 times 101 divided by 2, and we can get the total from there. So we get our series or arithmetic series formula from this formulation that Gauss had found at a very young age. So rule for arithmetic sequence: the a sub n rule is always for finding any particular term in the sequence. D in this case is the common difference. And then, of course, our sum is like the formula I just showed you, the number of terms times the sum of the first and last term, and then all divided by 2. So let's take a look at some sequences and determine if they are arithmetic. And then we are going to find the common difference. So let's start with 13, 21, 29, 37, 45. So to go from 13 to 21, we are adding 8. Then 21 to 29, we are adding 8. 29 to 37, we are adding 8. In fact, we are adding 8 each time. So yes, this is an arithmetic sequence, and the common difference is a positive 8. We can take a look at another sequence: 19, 4, excuse me, negative 11, negative 26, and negative 41. So to 19 to 4 is a negative 15. 4 to negative 11 is a negative 15. Another negative 15. It is consistent all the way through. So yes, it is. And in this case, D is negative 15. Let's do one more. So 4, 11, 19, 28, 38, and 49. The difference between 4 to 11 is 7, but the difference between 11 and 19 is 8. So we already know this is not arithmetic. There is no common difference. We can also write the rule for the nth term. Given some information. So 50, 44, 38, 32, and then find a sub 20. Okay, so we know that our rule is a sub n equals a sub 1 plus n minus 1 times the common difference. The common difference in this case is -6. When we go from 50 to 44, we are subtracting 6. So the common difference is -6. A sub 1 is 50. So we can write our rule, a sub n equals 50 plus n minus 1 times -6. And then if we are looking for the 20th term, then we're just going to substitute 20 in for n. And we get -64. So we found the rule for any term, and then we found the 20th term to be -64. Another situation that might come up is if you are given a particular term in the sequence, not the first one, so something like a sub 13 equals 30, and you're given the common difference, which in this case is 3/2 or 1.5. We want to write the nth term rule. And again, we're using a sub n equals a sub 1 plus n minus 1 times d. So we have a point to use and we have the common difference. So we can solve for a sub 1. So we know that if n is 13, then a sub 13 is 30. So we're going to use that fact and we're going to say 30 is equal to a sub 1 plus 13 minus 1 times our common difference of 3/2. And then 12 times 3 is 36, divided by 2 is 18. So that means that a sub 1 is equal to 12 when we subtract 18 from both sides of the equation. So we can say that a sub n is equal to 12 plus the quantity n minus 1, and then times 3/2. We could also be given two terms in the sequence. So for example, we could have a sub 6 equaling 10 and a sub 21 equaling 55. And we don't know what the common difference is. But because these are arithmetic sequences, they are linear growth. So we can use basically slope formula. Common difference is like slope formula. So each of these are points, right? So if we have n equaling 6, it means we get 10 for a sub 6. And if n is 21, then we get 55 for a sub 21. So for the difference, using our slope formula, we would do 55 minus 10 over 21 minus 6. And so that gives us 45 over 15, or 3. So the common difference is 3. So using our arithmetic sequence nth term rule, we can find the value of n for which a sub n equals 40. So we have to solve for n, but to do that, we're also going to have to write the rule for the arithmetic sequence. And to do that, we're going to have to solve for a sub 1. So we can use either 610 or 2155 in this equation to solve for a sub 1 like we did in a previous example. I'm going to use 610. So it was the sixth term. It is 10. Our common difference is 3. So a sub 1 is actually negative 5. So we write our rule. A sub n equals negative 5 plus the quantity n minus 1, and then times our common difference, which, I guess I can write that in this case, is 3. So very much like slope-intercept form. You could think of the common difference as slope, n minus 1 being your x minus x sub 1 value, and then the negative 5 being your y-intercept. So very similar. So if we're looking for which value is 40, the first thing I'm going to do is add 5 to both sides. And minus 1 times 3. Since 3 is a factor, I'm going to divide by 3. And then add 1. So n is actually 16. So a sub 16 equals 40. For our last example, we are going to consider the following. Series. And it's a series because we are adding. We want to find the sum of the first 30 terms. So our series formula, going back to the beginning of the lesson and talking about Gauss, we know as S sub n equals n divided by 2 times a sub 1 plus a sub n. So we know what we're looking for S sub 30. And we know that a sub 1 is 4. What we don't know is what a sub 30 is. So a sub 30 is actually the value in the sequence, and then S sub 30 is the sum of the first 30 values in the sequence. So we have to go back to our a sub n to find the value of a sub 30. So we want to know what a sub 30 is. A sub 1 is 4, 30 minus 1, and then our common difference, if we look at the difference of each subsequent number, it's a positive 3. So a sub 30 is equal to 4 plus 29 times 3, which is 87. And so a sub 30 is equal to 91. So going back to, if we want to add up, going back to our series, arithmetic series formula, we've got the sum of the first 30 terms will be equal to 30 over 2 times 4 plus 91. So that's 15 times 95, which is 1,425. I will post the problems that are going to be due on Gradescope. I'm going to start cutting down the assignments, making them a little bit smaller, a little bit easier for you guys to manage and upload. Hopefully everybody's doing well.